Hi friends, my name is Mayur Ubade. I am an assistant professor in WIT Solapur. Today we are going to discuss about design of high rate trickling filter. First, let's see what are the learning outcomes. At the end of this session, students will be able to analyze the design of high rate trickling filter in wastewater treatment plant. Let's see the raw view of a trickling filter. On this part you can see a trickling filter which is sprinkled on the surface area of the media, and the water is passing down and it is collected from this side and it is taken down, and this is the feed pipe from which the water is taken up for the sprinkling system. So here, while designing the trickling filter, we have to understand and we have to calculate the height and the diameter of trickling filter. On this part, we have to understand what is meant by the recirculation ratio. Here, when the water is taken out as a effluent after the treatment, it is taken down to clarifier where the settling of the treated wastewater is happening, and the supernatant of this part is taken down and few part is taken for the next treatment, okay, and few part of the treated water is again recycled and it is mixed with the influent, and it is again taken up for the trickling filter of wastewater. So how much water we have to recirculate and mix with the influent? Okay, so the few part of the wastewater, when it is transferred and mixed with the influent, and the ratio of this volume of recycled supernatant to the influent, we call it as recirculation ratio. So in the design, three parameters are very much important for us. One is recirculation ratio, from which we can calculate recirculation factor. The second one is its height, and third one is its diameter. Okay, so let's see one example of design of trickling filter. Let us assume design for a high rate single stage trickling filter for treating a following wastewater of a town having a population of 40,000 persons, and few parameters which we had given here is the domestic sewage at the rate of 150 liters per capita per day, having 200 mg per liter of BOD. And the second part of influent which is coming is industrial wastewater at the rate of 0.25 million liters per day, that is MLD, having 600 mg per liter of BOD. Recirculation ratio given is 1.0. The BOD removal in the primary clarifier is given as 35%, and effluent BOD, which is desired for us after the completion of the treatment of wastewater in the trickling filter, must have 30 mg per liter. So what are the steps which are involved in the design of trickling filter? The first step is to calculate the total influent BOD. First, calculate the total domestic influent, that is 50 liters per capita per day multiplied by 40,000 persons will give us 6 into 10 raised to 6 liters per day. And what is the domestic influent BOD from the this total influent? That is 6 MLD multiplied by 200 mg per liter, which is given to us, multiplied by 10 raised to minus 6 kg per mg. So our answer will be coming out in kg per day. And what is the total answer after calculating? It is 1200 kg per day. So we are getting the total BOD from the domestic influent, which is 1200 kg per day. So the second part is the industrial BOD. It is calculated as 0.25 into 10 raised to 6 liters per day multiplied by 600 mg per liter, which is given to us, multiplied by 10 raised to 6 kg per mg. Fine. So by calculating all this, we will getting 150 kg per day. So what is our total BOD which is coming per day into the trickling filter? That is addition of 1200 plus 150 kg per day. So that is our total influent BOD is happening to be 1350 kg per day. Fine. So what is the second step? In the second step, we will calculate the BOD removal by filter. Okay, how much BOD is going to be removed by the filter? So first calculate the BOD applied to the filter. As we have been given that 35% of the BOD which is coming into the trickling filter has been removed by primary clarifier. So the remaining 65% we have to multiply by the influent BOD, the total BOD. So we will be getting the influent BOD which is coming into the trickling filter. So how we can write it? 1350 kg per day multiplied by 0.65, that is 65%, which will give us 877.5 kg per day. So this much amount of BOD is coming into the trickling filter. As we have been given the desired BOD in the effluent, that is the water after the treatment, it must have 30 mg per liter of BOD. So the total BOD left in the influent will be 30 mg per liter multiplied by 6 into 10 raised to 6 liters per day plus 0.25 into 10 raised to 6 liters per day. What is this? This is the total discharge which is coming into the water. Multiplying BOD in the form of mg per liter to the total discharge will be giving the value of mg per day, and we will be converting to kg by multiplying 10 raised to minus 6. Fine. So we will be getting in the form of kg per day. So by doing this calculation, we will be getting the total BOD as 187.5 kg per day. So how much the BOD which will be removed by the filter, as it is the influent BOD and it is the effluent BOD which is coming down. Fine. So subtracting the influent BOD minus the effluent BOD, we will be getting the total BOD which will be removed by the filter. So we can write 877.5 minus 187.5 in kg per day. So we will be getting 690 kg per day. So this amount of BOD will be removed by the filter. Fine. So let's see the third step. So what is the efficiency of the filter? So the efficiency of filter, that is E, will be given as BOD removed by that filter divided by the total BOD which is coming into the filter, that is total BOD present in the influent. So we can write it as 690, which we had calculated earlier, divided by the total BOD, that is 877.5, which we had also calculated earlier, multiplied by 100. So we will be getting as 78.63%. So what is the fourth step? How we can calculate the volume of filter? As we know the E, that is our efficiency, okay, and we also know the W, how much the total BOD which is present in the influent in the form of kg per day, we know. We don't know the volume and we also don't know the F. So what is F here? F is the recirculation factor and it is expressed as 1 plus R divided by 1 plus 0.1 R whole square. As we know the R, that is recirculation ratio, we can calculate the recirculation factor, and by applying this F into this part we can calculate F. So this whole formula which is of NRC formula, we can find out the volume of filter. So we had studied all the 4 steps. Let us have some few questions, okay, to understand in the deep an analysis of these 4 steps by taking some few questions. So let's have some few questions. The first one is recirculation ratio is limited to 3 for industrial wastewater, whether it is true or false. The second one is number of effective passes through the filter is known as. Let's see their answers. For the first one, recirculation ratio is not limited to 3 for industrial wastewater. And the second one is for the number of effective passes through the filter is always known as recirculation factor. So in the fourth step, after putting the values which we had calculated earlier, as we know E, W and R, and putting into the formula, we are getting the volume. Okay, this recirculation factor, as we know R, we have calculated from that part and we are getting 1.65, and putting this recirculation factor again into the NRC formula and we are getting the total volume. Okay, and volume is coming up to be 7200 meter cube. And what is the fifth step now? Now in the fifth step, we will be finding out the dimensions of filter. For that, we have to assume first the depth of the filter. We always assume the depth of filter between 1.5 to 2 meter. Okay, here we are assuming height as 2 meter. And as we know the surface area formula, volume divided by depth, we can calculate it because we had calculated the volume earlier, which is coming up to be 7200 divided by the assumed depth. Here we had assumed the depth, and by putting up we will be calculating the surface area. Okay, and now by that we will getting the 3600 meter square as a surface area. From the surface area we can calculate easily the diameter. As we know the formula, surface area is always equal to pi by d square by 4. Okay, and here d is our diameter, and from that we can calculate the diameter. This is the surface area, that is 3600, which is equal to the value of pi, that is 3.14, multiplied by d square divided by 4. From that we can calculate the diameter of filter. Fine. So again let's have some review questions. So NRC formula is applied when the answer above it is the sewage load is highly variable. Now you have to understand where the NRC formula is used. NRC formula is always applicable when recirculation is not considered. Okay, large variation temperature is not present and the sewage load is highly variable. I have used these three references. Oh, thank you.